are the seminiferous tubules. And then from there, they are propelled into what structure? They're leaving the testes. Not quite, it's just before that, the straight tubule. Okay? The straight tubule or the tubuli recti. And then we would have the reading testes. Now we're out of the testes. Efferent-ductal. Connecting the testes to
epididymis.
The epididymis. And in the epididymis we have head, body,
tail,
and tail. Okay? Emission, if you recall, was the sperm leaving the tail of the epididymis and passing through the, what's the long tube that goes through the efferent canal? Okay, the vas deferens or ductus deferens. And the last dilated region of the ductus deferens, ampulla. And then it joins secretions from the seminal vesicle and enters the urethra. So that is emission, going from the tail of the epididymis into the urethra. Right? And that was kind of where we stopped on Tuesday. So we'll finish up with that today. So we'll put ejaculatory duct. And then from there, it passes through the three components of the urethra. Prostatic urethra, membranous, and we haven't covered this yet, so if these words sound new. So passage through the urethra is another E word. We call that ejaculation. Okay? So movement of the sperm and glandular fluid from the tail to the vas ejaculatory duct is emission, and then movement through the urethra is ejaculation. So the neural control of that, and which muscles contract and what's the sensory reflex pathway, we will cover tomorrow in the lecture hall. We talked about two glands contributing secretions to the sperm on Tuesday. We had the seminal vesicle. What were some of the contents of that glandular fluid that comes from the seminal vesicle or the seminal gland? Okay, fructose or citric acid used for what? Okay, that's how the mitochondria make ATP without having to go through the glycolysis components. They use that directly. Prostaglandins. The prostaglandins are named for the prostate, but they actually come from the seminal vesicle. And then a couple of other things that also the prostate gland will secrete as well. Everybody remember? Okay, fibrinogen is one of the clotting agents. And then fibrinolysin, which breaks down the clot. Okay? So that's coming from the seminal vesicle. The prostate gland releases those same clotting agents, bicarbonate ions, they both will release, and then some antibiotics to help protect the sperm as it passes external to the body. And there's one gland that we didn't talk about, and that's the bulbourethral gland, also known as Cowper's gland. Okay, so either term you can use. In the female, there's a similar gland. Bulbourethral can be used for both male and female. It secretes as part of emission but it goes below the prostate into the urethra, and it's going to also flush out. It's going to be secreted before ejaculation, and it's going to flush out as well any residual urine and help to lubricate the surface of the penis. So now we're going to talk about the rest of these structures that form the penis itself. And this has always been kind of a weird view because it doesn't help to understand the structure of the penis. And I believe it's on Tuesday that we're going to be using the modeling clay. So we will have talked about female erectile tissue by then. So be sure you have your modeling clay by then. Play-Doh's fine. It just makes the penis a little droopy. So either one is fine. So what's the structure of the penis? We have 3 bodies of erectile tissue. I'm going to draw a diagram. I'm going to take you through some images from Netters to explain this image a little bit better. And in the first image, we're looking at a male lying on his back with his legs up and knee support. This structure right here is the ischial tuberosity. So this is a female pelvis, but you're looking at it in this view. So the ischium, remember ilium, ischium, and pubic bones are the components of the os coxae. So this structure right here is the ischial tuberosity. And then this portion right here is ischial ramus and inferior pubic rami. So we're going to have our erectile tissue, part of our erectile tissue attached to that. Right. In the female, you would have the vestibule here. We'll see this on Tuesday with the opening of the urethra and vagina, and then the opening of the anus. So this triangle that's drawn here is known as a urogenital triangle for urinary and reproductive components. Now if we take the skin off, again, here's the ischial tuberosity. All right. And here is, I don't know if you guys that didn't have me last semester learned the levator ani. It's a muscle, actually it's a series of 3 muscles that forms the floor of the pelvis and contributes to the external anal sphincter. And so it would fit, what's it called again? Levator ani. So if you, as a female, if you've been instructed to practice the Kegel exercises to help support pelvic organs, that's the muscle that one of the muscles that you're contracting. I'm trying to get a pin in this plastic hole here. Anyway, so it fits like this. Okay, so it forms this pelvic sling. And then the muscles that we're seeing, so that's that one. And then the muscles that we're seeing here, remember this is a female, so they're going to be a slightly different relation. They have to separate to go around the vagina. So then this fills in this space right here. So the mylohyoid forms the floor of the mouth. It kind of fills in the triangle created by the mandible. So this muscle right here is covered by this fascia, and I'll draw it on the board to make it a little bit clearer. So it's kind of that image there, is the external urethral sphincter. And then these are muscles that are covering the erectile tissue. So it's been partly removed, and you can see some of the erectile tissue in the female here. And we'll be doing that on Tuesday, because this is the female model. So now on the board, can I erase the sequences here? I did do that in the earlier lecture, and it kind of compressed my boardroom. So pubic symphysis. Ischial tuberosity.
Thanks, guys.
And then this would be ischial ramus and inferior cubic ramus. And of course, we have our obturator foramen over here.